back to ASMR Nerd. Tonight, we're going deep. Settle in. Find a comfortable position. Let your body grow heavy. There's much work to be done, but it is quiet work, slow work. The kind of work that unfolds over centuries and a millennia. But together, you and I, we're not just stargazers tonight. We are world builders. And we will begin the great generation-long project of transforming Mars. One of my favorite topics and subjects. So close your eyes. You don't need to do anything at all. Just rest. Just listen. Your journey to sleep begins right now with this first step. Warming the cold heart of a distant world. So relax, lie down, get comfortable, and let's begin. Before we can start our work, we have to understand the task ahead. Let's just drift into orbit for a moment. High above the silent, ruddy sphere of Mars. From here, it's a world of breathtaking desolation, a globe of rust and butterscotch, butterscotch. You can see the vast scars of the valleys and marinas and craters that hold ancient memories of a violent past. The planet below it's cold. The average temperature is a harsh minus 63 degrees Celsius. It's a cold that has settled deep into the bones of the world, freezing its waters and thinning its air. The atmosphere that's left is a ghost with a pressure that's less than 1% of Earth's. It's about 95% carbon dioxide, but there's so little of it that it offers no warmth, no real shield, and too weak to protect the surface from radiation. If you were standing on the surface, the sky would be a pale, pinkish, hazy thing. Not the vibrant blue of home. So tonight, we arrive above this red, dusty world. Notice the two polar caps, brilliant white against the red rock. These aren't just water ice like on Earth. The Martian poles are a layered mix of water, ice, and frozen carbon dioxide, what we call dry ice. With every season, this dry ice supplements directly into the atmosphere in the summer and freezes back onto the surface in the winter. It's a faint planetary breath. But it isn't enough. From up here, we can detect the planet's vast reserves of water, while only a tiny bit exists as vapor. Enormous quantities are locked away as ice. Some estimates suggest there could be more than 5 million cubic kilometers of ice near the surface, mostly at the poles. If you could melt it all, it might be enough to cover the whole planet in a shallow ocean over 35 meters deep. And there's likely even more buried deeper down. promise of a blue future. But Mars isn't just cold, it's unprotected. See, billions of years ago, the planet's dynamo of liquid iron, which once generated a protective global magnetic field, just stopped. The core is still liquid, well, we think, but changes in how heat flowed through the planet shut down that dynamo down. Without this shield, the solar wind, a constant stream of particles from the sun, has spent eons and eons stripping away the Martian atmosphere. Any new atmosphere we build would suffer the same fate. So our task has 4 parts. We must protect the planet. We must raise its temperature. We must thicken its atmosphere. And we must change the air so that life can breathe. So this is the planet before us. A silent, sleeping world, waiting for a dawn it can't bring on its own. Our work will be a slow, patient coaxing of this world back to life. And it begins with an utmost unimaginable task, giving Mars a new shield. So our very first job is maybe the most audacious. We have to give back, or we have to give Mars its magnetic field back. A shield to protect it from the relentless solar wind. Without it, any temperature we build will just be scurried away. Well, since we can't just restart the planet's core, we have to build an artificial one. Now, there are a few ways we can try this. And one of the most elegant, one of the most fascinating proposals doesn't involve the planet at all. Instead, it involves one of its moons. Let's turn our attention to Phobos. The larger of Mars' 2 small moons. It orbits the planet swiftly, making a full circle every 8 hours. Now imagine a network of stations on the surface of this little lumpy moon. These stations start firing energy beams at the loose soil and rock on Phobos' surface. The regolith, just energy to vaporize the material and ionize it, creating a cloud of charged particles of plasma. Powerful electromagnetic accelerators that gently nudge this plasma, ejecting it into Phobos' orbital path. Slowly, the particle by particle stream of plasma begins to flow over the moon. Over months, then years, the stream spreads out, forming a vast, invisible ring of charged particles that encircles Mars. It becomes a plasma torus, a donut of electricity flowing right along the orbit of Phobos. Donuts. It's a simple bit of physics, really. A current of electricity generates a magnetic field, and this planetary scale ring of current generates a planetary scale magnetic field. It's an artificial magnetosphere, born from engineering and patience. A shield, custom made, really. Now this is a highly speculative idea, friends. A concept. But it's an elegant one because it's inspired by natural phenomena. Like the plasma torus Jupiter's moon creates. With this shield in place, the solar wind no longer slams into the upper atmosphere. It's deflected millions of years slows to a crawl. The surface is now protected from harmful cosmetic rays. Now, let me show you what that feels like. Safe. You are safe. You have drawn a line into the cosmos, a boundary that says, this far and no further you shall not pass. We have made the planet safe. Now we can begin to make it warm. And so we drift into the next phase of our great work. With our magnetic shield humming silently in place, we can turn to our second great task, warming the planet, my favorite. Now, to unlock the water and thicken the atmosphere, we need to raise the average temperature by tens of degrees. This won't be fast, but a gentle, persistent nudge over more than a century. First, imagine we deploy mirrors from assembly station in orbits. Vast feather-like structures unfold. Orbital mirrors made of reflective mylar. One older idea envisioned a colossal mirror, maybe with a radius of 125 kilometers, built right there in orbit. Placed in just the right spot. It could catch sunlight that would have missed Mars and reflect it down onto its surface. Imagine this great mirror, a man-made star, hanging in the Martian sky. Its light is focused on one of the polar caps. Let's start with the South Pole, where a huge deposit of frozen carbon dioxide sits. The focused sunlight is a gentle but constant pressure of warmth. The temperature of the ice caps slowly begin to rise. We don't need to melt it all at once. Even a rise of just a few degrees is enough to begin a cascade. As the dry ice warms, it turns directly into carbon dioxide gas. A great invisible plume rises from the pole, adding mass to the thin atmosphere. And carbon dioxide is a greenhouse gas. As its concentration increases, it begins to trap more of the sun's heat. Now, older ideas imagine this could kick off a runaway greenhouse effect. But here's the thing, friends. More recent science suggests Mars probably doesn't have enough easily accessible CO2 for that to happen on its own. So think of it not as a runway, but as a gentle, persistent push. The first nudge to get the planet's own system to help us out. To help it along, we have another method. On the surface, automated factories begin their work. I remember seeing this on Futurama, I think. But I did my own research too. So on the surface, automated factories begin their work, pumping potent heat-trapping gases like fluorocarbons, right? PFCs, into the atmosphere. These gases are thousands of times more effective at trapping heat than carbon dioxide. These factories would draw their materials right from the Martian soil, steadily adding a thermal blanket to the world. Incredible. Our third method is the simplest of all. We dispatch rovers across the ice caps to do just one thing: spread dust, dark dust. The simple act changes the albedo, the reflectivity sea surface. The brilliant white ice, which reflects sunlight, is now darkened. The dark dust absorbs more solar radiation, converting light into heat. A simple, elegant assist. Decades pass. The mirrors shine. The factories pump. The poles, darkened with dust, shrink a little more each summer, releasing their ancient stores of carbon dioxide. The average global temperature slowly, steadily climbs. From a frigid minus 60 degrees Celsius, it creeps upwards minus 40, minus 30. The warming doesn't just release CO2, friends. It begins to stir this vast amounts of water ice frozen in the soil. As the ground warms, subsurface ice also begins to sublimate, adding water vapor, another powerful greenhouse gas, to the thickening atmosphere. We have tipped the scales just a little, and the long winter of Mars is the beginning to the end. The warming has begun a profound transformation. For the first time in eons, the atmospheric pressure is rising. It passes a critical threshold called the Armstrong limit. Below this pressure, liquid boils away instantly. Above it, it has a chance to exist. The sky, once a pale pink, begins to deepen in color. With more molecules to scatter sunlight, it shifts towards a richer blue. The first clouds of water vapor begin to form, white and tentative. The promise of rain on a world that has been dry for ages. But this new atmosphere is still almost pure carbon dioxide. We need to add a buffer gas. We need nitrogen. So our work must extend beyond Mars itself. This is where the project becomes a truly immense, almost like something from science fiction. Imagine missions venturing out into the asteroid belt. They find a suitable amino-rich asteroid, a compound of nitrogen and hydrogen. A propulsion system is attached with a long, slow-burning, lasting years. The asteroid's path is precisely altered. It's placed on a course to gaze the upper atmosphere of Mars. The asteroid enters the atmosphere as a brilliant man-made meteor, and heat vaporizes the frozen amina, releasing nitrogen and hydrogen into the air. This is a highly speculative idea, friends, with an enormous engineering challenges we have yet to resolve. But we would repeat this process decade after decade, gradually building up the nitrogen content of the atmosphere. And now, with a thicker nitrogen-rich atmosphere and temperatures rising, the next great milestone is reached. The Great Thaw. The water ice locked away for billions of years start to melt. At the edges of the shrunken polar caps, trickles of liquid water appear. In the vast northern lowlands, the ground softens. Water trapped as permafrost begins to melt from the top down, and the first ponds appear, shallow, briny pools, reflecting the new bluer sky. They're incredibly salty at first because the Martian soil is full of salt like perchlorates. This actually helps though, since salt water freezes at lower temperatures. Over centuries, these ponds grow and merge. Rivers fed by melting glaciers begin to flow, following ancient riverbeds. They carry salt downstream, slowly depositing them into the growing seas. An ocean is born in the northern hemisphere. It's not a deep, globe-spanning ocean like Earth's, but a shallow, cold, and salty sea. And with it, the water cycle begins to turn. Water evaporates, forms clouds, and falls as rain or snow. We have given Mars air and water. The silence of eons is broken by the sound of the wind and flowing water. The stage is set for life. The planet is now warm, wet, and shielded, but it is sterile. The air is still mostly CO2. The soil, through damp, contains toxic perchlorates. It is time to introduce the pioneers. This is the work of bioengineering. On Earth, we have found organisms that thrive in the most extreme environments. Extramophilies. These are stock from which we will draw our Martian pioneers. Using synthetic biology, we can engineer a suite of microorganisms, each with a specific job. The first to be released are the detoxifiers. We seed the damp soils and the shallow seas with bacteria genetically modified to consume the perchlorates. For these microbes, the toxic chemicals are food. Now they don't just release oxygen into the air, they use it for their own metabolism. But by engineering them just right, the hope is that they could be made to slowly add a trickle of biological oxygen to the atmosphere. Next comes the soil binders and the nitrogen fixers. We introduce cyanobacteria that form biological soil crusts. They spread across the plains, their filaments binding the loose dust together, which could help reduce the severity of the planet's white dust storms. Other bacteria pull nitrogen from the air and fix it into the soil, preparing it for future plants. The first phase of seeding it's slow. For centuries, the only visual change is the red soil taking on a darker greenish black hue in the wet areas. Now, we can introduce the very first true photosynthesizers on a massive scale, like lichens and mosses. They are incredibly resilient. We see the rocky highlands with lichens adapted to the thin air, and they begin to pump oxygen into the atmosphere in earnest. Along the riverbanks, we introduce hardy, salt-tolerant mosses. The planet is beginning to turn green at its edges. This era, the oxygen revolution, is the longest and most patient part of the journey. Our journey. It could take many thousands of years. On Earth, this took hundreds of millions of years. So even with our help, we are asking biology to perform a planetary scale transformation. The oxygen level creeps up percent by percent. As it does, it forms an ozone layer supplementing our artificial shield. During this long twilight age, the pressure increases to the point where maybe you could walk outside with only an oxygen mask and not a full pressure suit. That's the goal, friends. That's the goal. We are no longer just builders, we are gardeners. The world is breathing. It is a slow, shallow breath, but it is the breath of life. And with every breath, it prepares itself for the next glorious, 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 glorious step. After many thousands of years, if all this work has paid off, the atmosphere of Mars has been transformed. Let's imagine the oxygen level has climbed to nearly 10%. The soil is now rich with organic matter. It is time to plant the world. We begin with grasses, tough prairie grasses designed to withstand cool temperatures, sending deep roots into the soil. Within a few generations, great grasslands stretch across continents, swaying in the wind under a blue Martian sky. With the grasslands established, we can introduce the first trees. This is a moment of profound significance. The first saplings are planted in the low-lying Hellas Basin. These first trees are pioneers like the conifers and birches of Earth. They are engineered to be incredibly hardy, with dark needles to absorb maximum sunlight. So for the first time, the sound of wind is not just a lonely howl across empty rock, but the soft whisper through pine needles. From Hellas, the forest spread. We're not just planting trees, we're building ecosystems. We introduce fungi, the insects, the worms. Imagine walking through a forest of Martian redwoods, their trunks reaching for a sky where the tiny disk of Phobos glides past. Imagine groves of trees adapted to the lower gravity, growing taller and more slender than their cousins on Earth. Imagine the scent of pine and the damp earth on the cool Martian air. With the forest, the planet's climate stabilizes. The vast biomass acts as a huge carbon sink and oxygen factory. The planet is now self-sustaining biosphere. Our great work, the project of generations, is nearing its completion. The red planet is now a memory. In its place is a living world of blue oceans, green continents, and white polar caps. We have built a new world together. From a cold, dead rock, we have cultivated a garden. This long, quiet work is now done. The planet is alive. Your own work for tonight is also done. There is nothing left to do but rest. If you're still with me, that's good. That just means your brain is holding just a little longer. And if you're enjoying this, friends, a like would mean the world to me. I know most of you would be asleep before this ends, and honestly, that's the goal. That's why I'm asking now. So just, if you can, before you go, consider giving it a like, and even subscribe for more quiet explorations. But that is a task for another day. For now, just let go. Feel the gentle pull of sleep, as gentle as the new gravity of our garden world. The great project is complete. The Martian forests are whispering in the wind. The waves of the northern ocean are lapping against ancient shores. It's a world at peace, and now it is time to find your peace. It is time to let your mind drift, to let this story fade, and to settle into a deep and restorative sleep. Good night, my friends. Sleep tight. visiting ASMR Nerd Herd.